Cofferdams are essential temporary structures that create dry work environments for construction projects and water. They help minimize risk, save cost on dewatering, and protect the environment. Whether it's bridge construction or environmental remediation, cofferdams are crucial for safe and efficient marine construction. In this video, we'll explore the different types of cofferdams, their installation processes, and best practices. Before we begin, we want to thank our sponsor and good friends at Jet Filter Systems. If you want to prevent retaining and seawall failure, well, how about saving money on repairs? Check out jetfiltersystem.com to learn more about their super efficient weep hold filters. Now back to the video. Types of temporary cofferdam systems. Temporary cofferdam systems come in various designs, each suited to specific site conditions and project requirements. Understanding the different types, their construction processes, and their advantages and disadvantages is crucial for selecting the appropriate cofferdam for any given project. Sheet pile cofferdams. Sheet pile cofferdams are constructed using interlocking steel or vinyl sheets driven into the ground to form a continuous wall. Steel is commonly used due to its strength and durability, but vinyl is also an option for less demanding applications. The installation process involves driving the sheets into the ground using vibratory hammers or hydraulic presses, creating a barrier to water. The enclosed area is then dewatered to provide a dry work environment. The primary advantage of sheet pile cofferdams is their strength and ability to form a tight seal. However, they can be expensive and require specialized equipment for installation. Earth-filled cofferdams. Earth-filled cofferdams use materials such as sandbags, rock fill, or earth to create a barrier. Common types include sandbag cofferdams, which are quick to deploy, and rock fill cofferdams, which provide substantial stability. The construction process involves piling materials up to form a dam, with the weight of the fill material providing stability. The area behind the dam is then dewatered. Earth-filled cofferdams are relatively inexpensive and simple to construct. However, they may not provide as watertight a barrier as other types and can be labor-intensive to build. Braced cofferdams. Braced cofferdams consist of vertical walls supported by internal braces to withstand water pressure. The design includes vertical sheets or piles with horizontal braces or struts to support the structure. Installation techniques involve driving the walls into the ground and bracing them internally, followed by dewatering the enclosed area. Braced cofferdams are effective for deep excavations, but can be complex and costly to construct due to the need for extensive bracing. Cellular cofferdams. Cellular cofferdams are constructed from interlocking steel cells filled with earth or rock. The design involves large steel cells that are interconnected to form a continuous wall, which is then filled with earth or rock for stability. They're typically used for large-scale projects like bridge piers and dam construction, where significant stability is required. Cellular cofferdams provide excellent stability and are suitable for deep water applications. However, they require significant material and labor to construct. Double-walled cofferdams. Double-wall cofferdams feature two parallel walls filled with earth or rock for stability. The construction method involves building two parallel walls and filling the space between them with earth or rock. The enclosed area is then dewatered. These cofferdams are often used in situations where a robust and stable structure is required, like in deep water or where high water pressure is present. Double-walled cofferdams provide excellent stability and strength, but can be expensive and time-consuming to build due to the need for large quantities of fill material and the complexity of the design. Design considerations. Proper design considerations are essential for the successful implementation of cofferdam systems. Key factors to address include site assessment, hydrological and geological factors, load calculations, and environmental impact. Site assessment. Proper site assessment is critical in the design of cofferdam systems. This involves a thorough evaluation of the site conditions, including soil type, water depth, flow velocity, and existing structures. Understanding these factors helps in selecting the most appropriate type of cofferdam and ensuring its stability and effectiveness during the construction process. Hydrological and geological factors. Hydrological and geological factors play a significant role in the design of cofferdams. Hydrological considerations include water level fluctuations, current strength, and potential for flooding. Geological factors involve the soil composition, bearing capacity, and potential for erosion or seepage. Accurate assessment of these factors is essential to design a cofferdam that can withstand the forces exerted by the surrounding water and soil. Environmental impact. The environmental impact of cofferdam construction must be carefully considered and mitigated. Cofferdams can affect water quality, aquatic habitats, and sediment transport. Measures should be taken to minimize these impacts, such as using silt curtains, designing for minimal disturbance, and implementing best management practices for erosion and sediment control. Environmental assessments and permits are often required before construction can begin. Construction and installation. The construction and installation of cofferdams require meticulous planning and execution to ensure safety, efficiency, and stability. Key steps include site preparation, selecting appropriate equipment and machinery, following a step-by-step installation process, and addressing common challenges with effective solutions. Site preparation. Site preparation is the first and most crucial step in the construction and installation of cofferdams. It involves clearing the site of any debris or obstacles, leveling the ground, and setting up access routes for equipment and personnel. Proper site preparation ensures a safe and efficient construction process, reducing the risk of delays and accidents. Equipment and machinery. The selection of appropriate equipment and machinery is vital for the successful installation of cofferdams. Commonly used equipment includes vibratory hammers, hydraulic presses, excavators, and dewatering pumps. The choice of machinery depends on the type of cofferdam, the site conditions, and the scale of the project. Ensuring that all equipment is well maintained and operated by trained personnel is essential for safety and efficiency. Step-by-step installation process. The installation process for cofferdams typically follows a series of methodical steps. Driving piles or sheets. Depending on the type of cofferdam, steel or vinyl sheets or piles are driven into the ground using vibratory hammers or hydraulic presses to create a continuous barrier. Bracing and anchoring. For brace cofferdams, internal braces or struts are installed to support the walls against water pressure. Dewatering. Once the barrier is in place, water is pumped out from the enclosed area to create a dry work environment. This step requires continuous monitoring to manage water levels. Stabilization. The cofferdam structure is inspected. Any necessary adjustments are made to ensure stability and safety before commencing construction activities within the dry area. Quality control and inspection. Quality control and inspection are ongoing processes throughout the construction and installation of cofferdams. Regular inspections should be conducted to check for structural integrity, alignment, and stability. Quality control measures include verifying the installation of piles or sheets to the correct depth, ensuring proper sealing, and monitoring the effectiveness of dewatering. Documentation of inspections and maintenance activities is essential for compliance with safety and environmental regulations. Expert tips and best practices. Consider the following tips and best practices while working on your next cofferdam project. Choosing the right cofferdam type. Selecting the appropriate type of cofferdam is crucial for the success of a project. Consider factors like water depth, soil conditions, project duration, and budget when choosing between sheet pile, earth-filled, braced, cellular, or double-walled cofferdams. Consulting with engineers and reviewing past project case studies can provide valuable insights into the best type of cofferdam for specific conditions and requirements. For projects requiring a versatile and efficient solution, consider COFFERDAM, which offers robust performance and ease of installation in various environments. Effective project planning. Effective project planning is essential to ensure the timely and successful completion of cofferdam construction. Begin with a detailed site assessment and feasibility study, followed by a comprehensive project plan that includes timelines, resource allocation, and risk management strategies. Involving all stakeholders in the planning process and maintaining open lines of communication throughout the project can help identify potential issues early and ensure everyone is aligned with project goals.
Once again, we want to thank our sponsor, Jet Filter System. Check them out at jetfiltersystem.com or call 800-475-2029 to save money and prevent retaining and seawall failure.